Every morning, millions of people roll the dice on their coffee. Some days it turns out perfectly clear and bright. Other days it's a bitter sludge. But an excellent, balanced cup of pour-over coffee isn't a matter of luck. It is the result of a strict mathematical equation. Exactly 15 grams of coffee to 250 milliliters of water. To execute this equation, you need to replace guesswork with measurement. That requires a specific set of laboratory-grade tools: a pour-over dripper, a paper filter, a digital scale, a gooseneck kettle, and a Brew grinder. By treating this daily routine as a controlled experiment, you eliminate the fluctuating variables that cause sour or bitter flavors. You take total control over the physical properties of the brew. Step 1 is building your baseline. We start by placing the empty dripper and filter directly onto the digital scale. Tare the scale to 0. Then, carefully measure out exactly 15 grams of whole coffee beans. This chart shows the spectrum of coffee strength based on weight. Dropping to 10 grams yields a weak, overly acidic profile. Pushing it to 20 grams produces an aggressively thick, overpowering body. 15 grams is your ideal balanced center point. Once weighed, the beans need to be processed. The size of your coffee grounds acts as the physical gatekeeper for the water, dictating exactly how fast the liquid flows through the dripper. For a standard pour-over extraction, we need a strict medium grind. This split-screen image compares ground coffee directly to standard coarse table salt. Visually, your coffee texture on the left should look and feel almost identical to the salt on the right. Missing this physical target guarantees a failed brew. If the grind is too coarse, water rushes through, leaving you with sour, under-extracted liquid. If it's too fine, the flow chokes, creating a harsh, bitter over-extraction. Now we introduce the water. Start your stopwatch and immediately pour exactly 40 to 60 milliliters, just enough to fully saturate the dry bed of grounds. Stop pouring. You are now in a strict 30 to 45-second waiting period known as the blooming phase. During the roasting process, carbon dioxide gas gets trapped deep inside the cellular structure of the coffee bean. Striking the grounds with hot water forces that gas to rapidly escape. This top-down time-lapse shows that exact chemical reaction taking place. The wet coffee bed actively expands, domes upward, and rapidly pops with tiny gas bubbles. If you skip this degassing period and pour all your water at once, the trapped gas forms a physical barrier. It prevents the water from reaching the natural oils, leaving the true flavor trapped inside the particles. Once the bloom finishes at the 45-second mark, resume your pour to drive the total water volume up to that final 250 milliliter target. This step requires strict kinetic movement. Maintain a continuous, slow pour, drawing concentric circles from the center outward. Keep your stream away from the very edges of the paper filter. Pouring directly onto the paper allows water to slip past the coffee entirely, diluting your extraction. Pace your pour to match the drain rate. You want to maintain a perfectly stable, unchanging water level inside the dripper cone until your kettle is empty. This stopwatch visualizes the final drawdown. Your metric of success is a brew time finishing between 2.5 and 3.5 minutes. If water drains before 2:30, your grind was too coarse. Draining past 3:30 means it was too fine. Landing perfectly inside this 1-minute target window proves your mechanics were sound. The physics of your grind and the chemistry of your bloom were executed flawlessly. To finish the process, simply remove the spent filter, give the carafe a quick swirl to mix the extracted layers, and pour your yield. The sensory payoff is a meticulously balanced cup of coffee. Because the extraction was controlled, there are no harsh, bitter flaws that require milk or sugar to mask. This reference chart displays the scaling matrix for larger volumes. If you need a larger morning dose or want to brew for 2, you can easily scale up to 300 milliliters of water with 18 grams of coffee, or a full 500 milliliter carafe using 30 grams. The underlying physics remain identical. The math scales linearly, maintaining the exact same extraction dynamics regardless of the final volume. By strictly adhering to these engineered steps and baseline ratios, you remove the guesswork from your morning routine. You stop hoping for a good result and start guaranteeing a superior cup of coffee.